Discussing further from the usage of the earth wire. So in a household circuit, live is there, neutral is there. I explained to you how the live and neutral are connected to sockets and other devices, and how within those devices then the electricity will flow between the 220 volt live and the 0 volt neutral. I also discussed that there could be one potential hazard, which is because of the wearing out of either the equipment or the wires, in which case a live wire could be in contact with some metallic part of the appliance. And if you happen to touch the metallic part of the appliance, then you are going to get an electric shock. In order to prevent this, household wiring is also wired with a third wire, which is done internally, which is the earth wire. Okay, and the earth wire is connected to devices in which such a risk is expected. So in mobile phones, you will not see this particular feature, but you will see it in things like electric irons, microwave ovens, convection ovens, refrigerators, etc., etc., where there is a significant risk of electric shock. And the way it is done is that this larger socket is connected to this earth wire. Okay, and when you look at the plug and the socket, they look like this. In order to, okay, I'll just complete this part of it. So the earth, oh, I made a mistake there. The live wire is connected to one of these. The neutral is also connected to one of these, and the earth is connected to this. Okay, so that is how the connection is made. Now we get into the situation. Imagine that that is what has happened, which is that the wiring has been compromised, or the device has been compromised because, I mean, the appliance fell down or something like that. Something became loose and the live wire came in contact with the body of the appliance. You haven't switched it on yet, but you are going to use the device. Okay, so you keep the electric iron ready, you plug the socket in, the 3-pin socket, and you put the switch on. Okay, now one part of it which I didn't complete is that the earth wire is kept in contact with the body of the appliance. The appliance is live now and the earth wire is connected to the body. Now logically think through what is going to happen. That's your first clue.
I didn't exactly understand the question.
Okay. Can somebody explain the question to Ishan? Maybe I can word that differently. Can somebody else explain it to Ishan? No, nobody understood the situation. So let me explain again, okay? Very quickly, an appliance has been compromised in the sense that a live wire has inadvertently made contact with the body of the appliance. The body is metallic, so therefore the body will become live when the appliance is switched on. So you plug in the appliance and you switch it on. Okay, Earth wiring is available and the earth wire has been connected to the metallic body of the appliance. So when you switch it on, what will happen? That is the question.
It should just flow back to the earth. As nothing should happen to you if you like
What will go back to the earth?
the current. The
The current, right? So what is going to happen is that the moment the live wire and the earth wire make a circuit, a large amount of current is going to be pulled into the circuit. Why is that? That is because the earth can accept a huge amount of current. Okay, so the current that is going to be pulled by the earth is going to become high. Will that by itself save you? It might increase your electricity bill, but it won't save you. So therefore, I introduce one more device that needs to be put in to complete the course. And that device is something called as the fuse. Okay, so what is a fuse? Let's consider a very simple, okay, there is a fuse called the cartridge fuse. It's basically a small cylindrical tube, okay, which has metallic ends, and the center part of it is actually glass, okay. And the thing is that this kind of a cartridge fuse is typically used in automobiles. You can also see it in some smaller appliances, okay. But I'm using this because it's easy to illustrate this. So the cartridge fuse has got a wire which has a certain amount of resistance, okay, and this cartridge fuse is then fitted in this circuit. So what they do is they fit the fuse in the circuit like so, okay, without the earth wire. So the earth wire, one part is connected on this side, another part is connected on this side. So that's the fuse. Now what is the advantage of this? So that wire that is there inside, that is the key thing. That wire has something called a fuse rating, which means that it will allow a certain amount of current to flow through it. Okay, so let us say that this particular fuse has a rating of 2 amps. Now if the current goes greater than 2 amperes, the wire is going to start heating up because it's a resistor, right? It has a certain amount of resistance. And what will happen when the fuse, when the amount of current exceeds 2 ampere, is that the wire becomes too hot, and then when it gets too hot, what will happen to it? It will
melt.
melt. Okay, so when it melts, what it will end up doing is it will end up breaking the circuit. Okay, so you will have a broken circuit over here, and if there is a broken circuit, then there will be no current that will be flowing through the circuit. Now, not deliberately but by mistake, I put the fuse on the wrong wire. So again, tell me, on which wire should I put the fuse in order for it to be effective? If you put the fuse on the earth wire, you will get electrocuted anyway. So that was a mistake, inadvertent one. So where should I put the fuse for it to be more effective?
Live wire.
Again, it has to be put on the live wire. So you put a fuse on the live wire like this. Unfortunately, the color is both ways is red, so I can change that to some other color. Maybe I make it brown. Okay, so I hope you understood what is the purpose of a fuse. The purpose of a fuse is that when there is excessive amount of current that is drawn through the circuit because of some short circuit that has happened, some appliance, the live wire has come in contact with its metallic body, then the earth wire which is in contact with the body completes the circuit. So a large amount of current is being pulled. That happens because the earth can accept a huge amount of charge. Then the amount of current drawn exceeds the rating of the fuse, heating up the wire, which is basically a resistor. And if it goes beyond the rated value, then the wire simply melts. And when it melts, it breaks the circuit. So then nothing in your house will work until you figure out. So when the fuse blows, you know that somewhere there has been a short circuit. You need to go and check your fuse carrier. They don't use cartridge fuses at home. In fact, they don't use fuses at all nowadays. There is another device called the miniature circuit breaker, which works on electromagnetism because it responds much faster. But in the olden days, we used to change, remove the fuse carrier, and we used to check the wire. If the wire has melted, then we have to find out where there is a short circuit, rectify that, and then replace the fuse and plug it back in before starting to use the electricity again. So basically, two ways in which we can prevent an electric short circuit. One is use a switch. Put the switch on the live wire so that when you put it off, there is no live point anywhere. The second one, which is a little bit more harder to understand, is the earth wiring. The earth wiring is a wire that is drawn around the house, same as a ring wiring, except that one end of it is buried into the ground to accept a large amount of charge, and the other end is connected to all devices in which there is a risk of electrocution. And then when there is an hazard that happens, so it doesn't normally happen, but over many years of usage, let's say that you put the wiring for something under the carpet and people were walking up and down on the carpet, and slowly, because of friction, wear and tear, the plastic insulation has got worn out. Now the metallic part is exposed, and because of that there is a possibility of a short circuit. Now the moment you switch on the circuit, the metallic part which is exposed will come in contact with the live wire, and that will draw a huge amount of electricity, and the huge amount of electricity will exceed the fuse rating. The fuse, which is a wire which has a certain amount of current that it can allow to pass through safely, beyond that limit the wire will heat up, it will melt, and it will cut the circuit. When that happens, you know there is a short circuit. Rectify the short circuit, replace the fuse, and you are good to go. So with that, we come to the end of this household wiring part of things. If there are any further questions, you can ask me now.